So hey, this is the organic reactions worksheet. I'm going to go through this with you as quickly as possible. You can stop and start as needed, but that's up to you. So the first one here, these are all different organic reactions. Some of them are organic reactions that I have not taught you, and that's okay. I will present them here so then you'll know. So the first one, it says it's an addition reaction, and when we look over here at the example, we can see that we have a double bond. And we know that if we have a double bond, we have to add because the two vowels go together, addition and unsaturated. So the description for this is an unsaturated hydrocarbon, and it's going to add across the double bond because it's going to break the double bond. And when we do that, we're going to get a chlorinated alkane. So that breaks the double bond. So it says a halogen's added to an unsaturated hydrocarbon after you break those multiple bonds. The next one says a halogen replaces a hydrogen on a saturated alkane. So if it's an alkane and it's saturated, you know the two S's must go together. So therefore, this has to be a substitution where we're adding fluorine onto the alkane. Well, we're not adding, we are substituting. So we're going to take off this hydrogen right here. So this hydrogen comes off. That hydrogen goes and works with the other fluorine. So we end up with hydrogen fluoride and a fluorinated alkane. The next one says joining many small molecules into one large molecule. And so that's going to be called an addition polymerization. It's not a condensation polymerization because it does not produce anything. What we're doing is we are breaking this double bond right here, all right? And so if we add, it's an unsaturated, so it's an addition polymerization, very similar to the last one we did. The next example shows you sugar, glucose, with the yeast creating an alcohol and ethyl alcohol and carbon dioxide. And you know that one as fermentation, and there's the definition. So in letter E, you're given a fat plus a base, and when you see a fat plus a base, you must know that that has to be saponification, which is the process where a fat and an alkali, an inorganic base, are converted to two things, glycerol and soap. Anytime you see that fat and a base reacting together, you got to recognize that as saponification. Letter F, you have to look at the equation that you're given, and you have to notice at first that you have the COOH right there, COOH. That's really terrible. It's like a mustache, not a parenthesis. There we go. COOH, C, double bond O, OH. That is an organic acid. And then we look over here and we have the OH, or HO, all right, OH, which is an alcohol, okay? So anytime you have that kind of situation together, you know that you're going to be producing a dehydration synthesis, and more specifically, a esterification. And so in esterification, we react the organic acid, like I said, with the alcohol, and the water is produced from the OH from the acid. Now, I don't know if I may have done this incorrectly before, but the OH from the acid and the H from the alcohol. And those two parts together are you going to make your HOH, your water, all right? That is H2O, HOH. Your ester is just now going to be the two parts joined. And here I've color-coded it for you. So the purple side is your acid side. The green side is your alcohol side. And so when you get done with this, then to name this, you always start with the alcohol as the substituent. So we have one carbon alcohol. So that's going to be a methyl, and then you look at the other part, the acid part, and that's going to be from propanoic acid. That's going to be called propanoate. So this ester would be called methyl propanoate. Letter G is a hydrocarbon combustion because you recognize that a hydrocarbon, namely propane, is reacting with oxygen and gives you carbon dioxide and water vapor, and that is a typical hydrocarbon combustion reaction. Letter H says we are breaking down large hydrocarbons with heat, pressure, and or catalyst into smaller, more useful sizes. This is something we haven't talked about, and this is something that's called fractional distillation. And fractional distillation is a process where you break large hydrocarbons into small hydrocarbons. There is a video that I want to show you. I'm not going to put the video inside this video, but I will link it so you can find it afterwards. So now we just have multiple choice questions of the same kind of nature. Number 2 says the process of joining many small molecules into a large molecule. That small molecules into a larger molecules, that is your clue that this is polymerization. Number 3, it says which reaction is soap a product. Soap is always going to be a product. It's saponification. Number 4 says given that equation, we have a saturated alkane. We add a chlorine to it. We now have a chlorinated alkane. That is not an addition reaction, but it is a substitution reaction involving a saturated hydrocarbon. We are substituting the chlorine for a hydrogen, and we have to do that because it is saturated. This one here, number 5 says base your answers to A through C on these. It talks about many artificial flavorings are prepared using this type of organic reaction. This is called esterification. Question B says to which class of organic compounds does reactant 2 belong? You got to be careful that you're looking for reactant 2. Reactant 2 is this one here. All right. Reactant 2, if you look at it, it only has an OH on it. So any compound that has an OH is called an alcohol. And then letter C says, draw the structural formula of an isomer of reactant 2. Well, reactant 2 could have a couple different isomers. We could have this isomer here, which is being a structural isomer, is the isomer of 2-propanol or isopropanol. Now that I look at the question, it says draw a structural formula of the isomer, of an isomer. That's one structural formula. That is called a positional isomer. We also have something that is called a functional group isomer. In the functional group isomer, we're going to change the functional group. Well, the functional group isomer twin of an alcohol is something called an ether, and this is the functional group isomer called methyl ethyl ether or methoxyethane. And number 6 is asking you to show what the structural formula for this reaction is going to be. We start by identifying the fact that we have an alkene. An alkene is an unsaturated. So if it's unsaturated, that means we're going to add to it. Unsaturated means we're going to add. So we're going to add the halogen across there. And when we do, we will break the double bond. And when we break the double bond, we can add the halogen where that double bond existed. Number 7 gives you a big reading section. Take a moment to read that. Hopefully you read that. So now, question A says, identify the type of organic reaction by which ethene or ethylene is converted into polyethylene. Well, a monomer changed into a polymer is called polymerization. Letter B says, according to the information in the reading passage, state 2 consumer products manufactured from ethene. I'm going to leave that one to you because it's right there in the reading. And then letter C says, explain in terms of bonding, so make sure you talk about bonding, why ethene is an unsaturated hydrocarbon. And again, I'm going to let you just do that one because that is simply the definition of an unsaturated hydrocarbon. If it helps, you may want to draw out the structural formula for ethene.